Okay, guys, so for this last section of Unit 15, two variable inequalities, we are looking at systems of linear and nonlinear inequalities. So our 3.0 content is looking at systems of linear inequalities, just linear inequalities. Okay, and our last section we just looked at was nonlinear inequalities. Okay, so our very last section of this unit is a system of both linear and nonlinear. Okay, so we should know how to graph both of these. We're just going to see what a system of them looks like together. Okay, for the first system, we're looking at y is greater than or equal to x squared minus 2x minus 8. Okay, again, we know that this is going to be a parabola. So what we can do is we can put this into our calculator. Okay, put this into our calculator. If you need any help trying to figure out how to put that in a calculator, you can come back and ask me. You can there's a lot of different things you can do on these calculators, but sometimes you just gotta try and figure it out and work through it. And once you get it, I promise it'll be more efficient. Okay. So these tables here is what's generated from that process that we went through last section after putting in our x squared minus 2x minus 8 into our calculator. Okay. So this here's our table right here. Okay. We can plot some points off that table. There's the point negative 3, 7. There's negative 2, 0. There's negative 1, negative 5, 0, negative 8, 1, negative 9, 2, negative 8. And as we can see our parabola shape start to form here. Now, we should know that this is going to be a solid boundary line because it's greater than or equal to. It's got that line under it, right? So it's going to be a solid boundary line. Okay. Now, when I want to figure out which part of this I want to shade, okay, I can test the point 0, 0. Okay, we're used to doing this. When I pick the point 0, 0 and test it, I'm just going to substitute 0 in anywhere I see y, anywhere I see x in this top inequality. Okay, this whole thing here can simplify to 0 is greater than or equal to negative 8. And this is true, of course. Okay, now if we're getting confused on how we get from this step here to this step right here, just simplify this. We can't do anything with the left side. Okay, 0 squared is just 0. Negative 2 times 0 is just 0. So 0 minus 8 is just negative 8. Okay, and 0 is in fact greater than or equal to negative 8, which is true. So we will shade the half plane that contains our test point, which is 0, 0. So we'll shade the inside part of this parabola. Okay, so there we go, getting that. Okay, now for the next part, we have y is less than or equal to negative 2/3 x plus 4. And we should know how to graph this. Our y-intercept is the point 0, 4, and our slope is negative 2/3. Okay, so if I want to put a point at my y-intercept at 0, 4, right on the y-axis, I'd go up 4. Now my slope is negative 2/3. We're going to go down 2, right 3. Okay, down 2, right 3. Now this line is also going to be a solid line because, again, it has that line under it for our inequality. It's less than or equal to, so it's going to be a solid boundary line. Now to try and figure out which part of this inequality we're going to shade, okay, we can also test the point 0, 0 again. Okay, so when we test the point 0, 0, we see that this inequality here would simplify to 0 is less than or equal to 0 plus 4. Well, 0 plus 4 is just 4. So 0 is less than or equal to 4. This is true. So we would shade the half plane that contains the point 0, 0. Okay. So now that we have both of our inequalities graphed and shaded, our job is to erase the non-overlapped parts. Okay. When we erase the non-overlap parts, we're left with just this inside part of the parabola that's below our linear inequality. Okay, so this would be our solution to this one. Okay, so this whole process is really no different than what we did in the 3.0 content when we were dealing with linear systems, but the only difference is now there will be one that is nonlinear. Okay, the process is still the same. We'll still test points. We'll still generate our table for our nonlinear ones. Okay, we'll do all that process the same, and we'll erase the non-overlap parts. And the part that is overlapped, that's our solution. Okay? So, looking at the next one, we have y is greater than 3x minus 9. Okay? When we look at this one, we know that our y-intercept is going to be at the point negative 9. Okay? So that's that point that we just plotted right there. That's our y-intercept. Okay? Now, our slope is 3, so we're going to go up 3, right 1, up 3, right 1, up 3, right 1, until we can't anymore. Okay? Now, this is going to be a dash boundary line. The reason this is dashed is because our inequality is strictly greater than. There's no equal to part. It's just greater than. Okay? Now, when we try and test a point here, we could pick the point 0, 0. But some of us were kind of getting the hang of the fact that, well, this is greater than, which part of this line would be greater than the values on this line, the stuff above it or the stuff that would be below it? And a lot of us were saying, well, greater than's above. Okay, so we can kind of use that for our judgment as well. Now for our next inequality, we have y is less than negative x squared plus 4x plus 5. Okay, so this table I'm pretty sure was generated from Desmos. Okay, negative x squared plus 4x plus 5. This is going to be a similar table that the calculator will give you as well. So whatever you're more comfortable with using, I say use whatever you want. Okay, so we can plot these points. There's my point negative 2, negative 7, negative 1, 0, 0, 5, 1, 8, 2, 9, 3, 8, 4, 5, 5, 0, and 6, negative 7. Okay, now this is also going to be a dash boundary line because it's strictly less than. There's no equal to part. Okay, now to find out which part of this we're going to shade, we could also test the point 0, 0 again. So 0, 0 is not on the line. It's right here. Okay, when we plug 0, 0 in, we get 0 is less than 5. Okay, because negative 0 squared is just 0, plus 4 times 0 is just 0. Okay, 0 plus 5 is 5. And of course, the 0 over here would just stay 0. So 0 is less than 5. That is a true statement. So we would shade the half that is containing our test point, which is right here. So we'd shade the inside of this parabola. Okay, notice how we're shading the whole inside of that parabola, guys. I think a lot of us are stopping at different boundary points. Yes, this section right here, that's the overlap, is gonna end up being our whole solution. But a lot of us are stopping our shading early, and I don't know if it's because we don't want to erase or what, but we want to make sure we see the whole picture so we can see everything that's overlapped. Okay, so when we erase our overlap, we are left with that section there that we were just talking about. Okay, so that would be our solution to this system of inequalities. So our system of linear inequalities is similar to our systems of nonlinear inequalities in the sense that we are still shading and testing points and trying to figure out which parts overlap. The only difference is how we go about graphing the nonlinears versus the linears. Okay, so that is it for the last section of Unit 15.